Hello, and welcome to episode 203 of The Joy of Coding. Hi, I'm Mike Conley. Nice to see you. How's it going? I'm going to tell the folks right now who might be hanging around in the Twitch chat watching this live. I'm not in the Twitch chat because I couldn't get my IRC. Like, I've switched to a new machine, and my IRC client is being... You know what? Now that I think about it, though, I can just... Instead of using IRC... I'll just use the browser. I'll just use the browser to connect to the Twitch chat, and then I will be able to Twitch chat. I'll just have to make sure that I'm like muted so that you don't hear me while at the same time streaming. All right, I am now in the Twitch chat. Hello. Okay, where was I? Yes, welcome to episode 203 of The Joy of Coding. Let's get started. Let's get started. Okay, so here's the agenda. For the folks who are new, maybe the folks who haven't seen this before, a reminder, no plan survives breakfast. I don't know what's going to happen during today's stream. I might get distracted, I might get stuck, I might go down a rabbit hole, or we might find some stuff and fix a bug. Who knows what'll happen? Like right now, I've just realized, for example, that I'm running on battery, and I need to plug in my laptop, and who knows what that's going to do whenever I pull this cable. Hopefully it doesn't undo all this stuff underneath me, and hey, we got power. So like that sort of thing. None of it's rehearsed. Anything could go wrong. The stream might cut out intermittently. Who knows? Rabba-da-babba-da-babba-da-babba-da-babba-da-ba. Rabba-da-babba-da-babba-da-babba-da-ba. So... Yeah, no plan survives breakfast. The agenda that we're looking at is something that you have access to. If you're watching this on Air Mozilla, for example, it'll be in the video description to my right, your left. No, my left, your right. If you're watching this on YouTube, then in the video description down below, you can find a link. And if you're watching this on Twitch, then let me just drop the link into the Twitch chat like this. There's the agenda, everybody. All right, the agenda. And I also want to point out that there is an episode guide. The episode guide is completely viewer-driven by viewers just like you. And unfortunately, it went to the most recent browser window, which was the one I just opened. So I have to copy the episode guide. Yeah, this is the episode guide. And we've got all the way up into episode 201, which was at the very beginning, or the very end of 2019. It was the last episode of 2019. And this is the episode guide more or less lays out what the episode covered, maybe some of the bugs I touched, some handy links, maybe notes for the bugs, that sort of thing. And it, like I said, it's completely viewer-driven. So if you are interested in maybe supplying some notes or addenda or corrections, or if you want to expand upon something that I talked about, you can send a pull request to the GitHub repository. Both the links to the episode guide and to the repository, as well as a contributing guide if you want to contribute some text to the episode guide. That's all here in the agenda. And I will note that there is a pull request already for the last week's episode. And as per tradition, I will attempt to merge this in. And what's interesting about this one is that it is the first episode of 2020. So we're going to get to see if the rollover works correctly. I believe it shall, because it worked for 2018 and 2019 and 2016. Like basically, we're going to be adding a new entry here, but it all happens automatically by the power of Jekyll. So let's see if that happens. But first, let's double check the links here inside the pull request. Make sure that this is for episode 202. It is. Make sure that this agenda is pointing to the right thing. Episode 202. Yep, that looks right. And then what were the things that we covered? Well, we got Wacky Morning DJ working again. We did some code review of a bunch of stuff. I mentioned that we were switching from IRC to Matrix/Riot. Well, we're switching to Matrix. Riot is one client you can use. And it's probably the client most people will use. But Matrix is a protocol like IRC. And there are a number of alternative clients if you don't want to use Riot. It was indeed fixed in next build. I'm not sure. Oh, the about dialogue being broken. Yeah, and so I'm going to correct a small grammatical error here, but no big deal. There was no stream on the 29th. Yeah, that's right. Next week I will have a stream, but the week after that, no stream, and the week after that, no stream, because I'm going to be away. So I also had a mustache, I had a new microphone, I upgraded the computer. Yeah, all this looks great. So what I'm going to do, though, is I'm going to quickly edit this file. I'm going to add a new commit here, because it was indeed fixed in the next build. In the next build. Okay. Yeah, there was a bug that people noticed where like the about dialogue looked strange, and I think it's been fixed. So this looks good to me. I'm gonna merge this in right now. Thank you so much, SmurfD. As usual, an amazing, you're an amazing person. You're like definitely the dominant contributor to the episode guide. So thank you, SmurfD, the best. And hopefully we're going to see the rollover occur whenever the GitHub pages refresh, and we'll see 2020 being listed here. I don't know how long it takes. Maybe it might take a couple more minutes, but I'll keep refreshing, and eventually we'll see 2020. Anyways, that was the episode guide. Now, what are we working on today? We're not just going to be working on the episode guide. Well, there are two things I was hoping to look at. One thing might take the entire episode. I don't know. And then the other thing is a fallback in case we get all this stuff done. What I want to look at is I'm hoping to help out one of my colleagues who's attempting to categorize a bunch of different. Well, basically, we have this observer notification. You can think of the observer service in Gecko as like this message bus, process-wide message bus that, SmurfD just wrote, maybe you could mention the 2 nice blogs you have written. So maybe before I continue, before I go deep, I will tell you about that. First of all, let me just refresh. Is 2020 here yet? Yes, it is. It worked. Yeah, Danny Quillen. The Jekyll stuff worked. Very good. So the 2 blog posts that SmurfD is referring to, the first one is this one. This is talking about picture-in-picture. I co-wrote this with Emanuela Damiani. I don't know if I'm pronouncing your last name correctly, and if I'm not, I apologize, Emanuela. But so let me, blog posts, Mike helped write. So I helped write this one, and then I also wrote one about Mercurial. Mercurial M. Conley. How I use Mercurial. And if you're ever interested in contributing to Mozilla, or like Mozilla Central, or any of the projects that use Mercurial, and you want to know how I use Mercurial, you might be interested in reading this document, because it talks about like my setup and what commands I use and how I use them and how I think about Mercurial. And it might not be like the most correct way of thinking about Mercurial, but it gets the job done, and ultimately that's what I care about. So yeah, if Mercurial is a thing that you sometimes struggle with, or you have curiosity about, maybe you've been using Git but you want to switch to Mercurial, hacking on Mozilla stuff, or maybe you want to see what it's like using Mercurial so you can make a decision on whether or not to use Git or Mercurial, maybe give this a read, or just watch some of my stream, because periodically you'll see me working with Mercurial, and you get to see how much of a struggle it can be sometimes. Well, sometimes it's a struggle and sometimes it's not. All right. Let's start with... let's see here. Let us start with... re-explaining the observer service. So there's this observer service that's like a process-wide message bus that you use to like inform other parts of the browser that something has happened. That's a pretty common pattern if you've ever heard of the like observer pattern. This is like is a service that implements the observer pattern that is process-wide. So there's like a singleton observer service, and you register observers that listen for notifications. One of those notifications that gets sent out is something called xpcom shutdown threads. xpcom shutdown threads is dispatched whenever... Here, let me actually look up the documentation, because I think we have some. We talk about xpcom shutdown here. Any non-main thread event queues should be finished by the... So whenever this notification fires, It's a signal that any non-main thread event queues should be finished by the module which owns them. So all threads running xpcom code should be joined up with the main thread. Any special services that might be required for like any kind of like component, any like stuff that's required by main thread services or components should be obtained and cached. Required for component loader shutdown should be obtained and cached by the end of this notification. Garbage collection will be performed at this stage. Let me see if I can find better documentation. I'm not entirely certain that's the best documentation. Mozilla Observer notifications. Observer notifications. Huh. So it's not listed here. Well, okay. So what it means is, hey, everyone, all of you non-main thread stuff, join up or finish up what you're doing because we're about to shut down a bunch of components. So if you're doing stuff that's off the main thread, you better shut down. And so Doug Thayer, one of my colleagues, put together this list of things that observe that notification. So these are things that probably have non-main threads that they are managing, and they need to hear about this because they hear about it on the main thread, and then they have to communicate, presumably with something off main thread, to say, I don't know, do some cleanup work, or maybe they just shut the other thread down, or maybe they don't do anything because that one thread doesn't do anything important. But like, what's key here is that we need to know the ones that flush things to disk. I think that's the important thing. The stuff that's trying to persist stuff, maybe there's an IO thread that's writing to disk. We don't want to interrupt that because that stuff that it's flushing to disk we probably need. You know, there's a reason we're writing it. It's probably so that we can like run next time and do something useful. You know, preserving user data, preserving user state. And so it does not make a good amount of sense to shut down that thread halfway through its write. We want it to finish the job. So we're mainly auditing these threads that are still operating at shutdown so that we can determine which ones need to stick around and which ones we can just like throw away. So already there's like, so Doug has set up this spreadsheet for us to work with, and these are the places where we've got these thread observers, and he's got some notes here. Now, I haven't really looked too deeply into the spreadsheet, and I'm going to take this opportunity now to read some of the notes he's written up. So he notes that that you'll probably want to go to latest version in the navigation box of search box in order to make it easier for you to click around the code. So all of these link to like their permalinks to specific revisions, but he thinks that it makes more sense to go to the latest revision to more easily navigate the code. Okay. So that's the link to the observer. That's not something I need to fill out. What I need to fill out are here and maybe here. So a brief description of the work that the observer does. So note, you may run into a lot of thread shutdowns here. What you need to know about NS thread shutdown is it will put a shutdown event on the thread's event loop and let the thread run that loop until it gets to that event. This means we need to consider all events which can be placed on the thread's event loop, since any one of them can be running at the time where we hit xpcom shutdown threads. I see. So it's possible that the thread is doing any number of things at shutdown time, and we need to understand what are the possible things that it could do. Can it be safely skipped? Generally, file/network reads and memory-only actions are entirely safe to skip during shutdown, whereas writes, so reads are okay, but writes are complicated and may require discussion with the team. And then who's investigating? So I'm assigned these three, 1, 2, 3. And then any bug numbers that we file. And it looks like, you know, Doug, that's D. Thayer here, has already done some investigation. Florian's already looked at one. Heiss is looking at these three. He's already looked at these three. And he's filled in some cells here. And so these are the three I have been assigned, and these are the ones that I want to look at today. So that's all to say that I have things I want to examine today. Let us examine them. So let's check it out. So this first one's called background impl. I don't know what it does. I think I've seen it before. This is part of the IPC layer. So that already this is going to be pretty. IPC means inter-process communication. This is part of the layer that does communication between processes, as you can imagine. And so one of the things that the observer does is, so I'm going to go to the latest version as per his instructions. So we receive the observation, the notification on the main thread, make sure that it's the shutdown threads observer ID notification, and then we tell this one thread, child impl, to shut down. Okay, so what is child impl and what is it doing? That's kind of the operative question here. That's the important question. What does this thing do, and what might it be doing when we tell it to shut down? So child impl shutdown, let's see what that does exactly. It's a static method that runs on the main thread. So we've got this, I guess, this class called child impl. It checks to see this static boolean, presumably, of whether or not we've already started shutdown, and if so, then we do some asserts. We assert that if the thread local index, I'm trying to think what that would be. Thread local index. Bad thread local index. What is bad thread local index? Or what kind of thread local index? A thread local index that is not valid. And then what do we do with it? When do we write to it? It's interesting that at startup we make sure that, at startup we make sure that the thread local index, and what it means by thread local is that each thread gets its own copy of this static variable, I think. And then what do we write to it? Yeah, right here. We ask for a new thread private index. I guess it's a new index for per thread private data table. This index is visible to all threads within a process. This index can be used with PR set thread private and PR get thread private routines to save and retrieve data associated with the index for a thread. Okay, so it's like, you can think of it as almost like the some kind of like identifier that's used for storing and retrieving data from a table, maybe. Let's go back down to the shutdown. So we make sure that if we have set it to something that's not the bad thread local index, so something that's not the default, that we cannot get at the thread. What does get thread private do? Recover the per thread private data. So we make sure that we can't get at the per thread private data. And we also check to see if the thread local index for the socket process is not equal to that. So it's like we do the same thing. Maybe there's a separate thread here for the socket process. Okay. We make sure we can't get at the private data. So maybe, oh, I see. So it's like if we re-enter this, we do some assertion to make sure that we've like made it so that we can't access the thread private data. But then we bail out because we add this shutdown has started. We set this to true on the main thread, and then if we re-enter this, we're just going to bail out over here. Okay. And then we say shutdown with thread local index. And I think that's the important part here. What that's going to do is we get, if we're a debug build, it will get the thread local information, like the private thread information, recover the per thread private data for the current thread. So we get that private data. And we try to, and we're going to assert that it exists. And if it doesn't, we're going to explode. Wait, no, we're going to assert that it doesn't exist. We assert that it is like falsy or null. Null pointer. That's interesting. Any questions so far? I'm still figuring this out. I've never read this code in my life, I don't think. So we make sure that we can't get any of the private data. And then if we set the thread local info to be either main thread info or main thread info for socket process, depending on whether or not a thread local index equals thread local index. What does this run on? Shutdown with thread local index. I think this is supposed to be running on the main thread, is it not? Shutdown with thread local index. Is it called from anywhere else? No. So we must be on the main thread. If we're running in here, we must be on the main thread. So then there must be like some main thread. Yeah, S main thread info. Got it. If the thread local index equals S thread local index, get the main thread info. Otherwise, get the main thread info for the socket process. Okay. And if we have such info, then in a debug build, we're going to make sure that the thread local info is not closed. And then we're going to set it to true. So we're going to make sure we have not done this before. And then we're going to call the destructor on the info. And if the thread local index is the S thread local index, we're going to set to null. So we're going to null out the pointer after we did, thread local destructor. Thread local destructor, what it does is we're going to get at the thread local info and then make sure that it's been closed. And then because like the earlier, before we called this, we had set close to true, okay? Then we're going to see if there's an M actor on it, and if so, we're going to call close on that, and then we're going to assert that the actor was destroyed, and then thread local info, send init background runnable. So what is this? If we were send init background runnable. That gets set inside getter create for current thread. So if we had set send init background runnable, is this? What thread is this on? Oh, sir. If we're on the main thread, then there's no main thread event target. So we might be running this on any thread, interestingly. But we only set this variable if we're not on the main thread. Okay. So there's a runnable that we will dispatch to the main thread. That runnable is this thing. We're going to create, we're going to move the P background parent, whatever that is, into this C++ lambda function. Brain's melting a little bit here, but we are going to get the content process singleton, and we're going to send an IPC message, send init background, and we're going to give it the parent. I see. So that's going to create the actor on the other side, in the parent side, I guess. Does that make sense? Wish I knew more about what this file does. It's kind of hard to understand. It feels like it's very complicated. Let me see if I can find some documentation. Background, parent, background child. These are the headers. Background impl, it imports both of them. You know what? I have a feeling parent impl, implements parent, background, parent impl. I got a feeling that background child impl, I got a feeling implements p background child and p background parent impl. Whoops, daisy. Implements p background parent. All right, I'm trying to understand the structure here. So we have this. It's getting warm. I gotta take off my outer shirt. Pardon me. Danny Colin wants to photonize searchfox.org. Patches welcome. Searchfox is actively under development. There is a GitHub repository. Where is that? There's a Bugzilla place where you can send bug reports, but SearchFox itself, where's the code? Doesn't it have a link to its own code? GitHub page, yeah. It's not very well advertised, but here's the link to the GitHub page right here. And like the last commit was 10 days ago. So it's not something we spend like an uproarious amount of time on, but like this one was updated 2 hours ago here apparently. I don't know how the linter was updated 2 hours ago if the latest commit was 10 days ago, but there you go. And there are instructions here on how you can get it set up. And I'm sure, Danny Colin, that Andrew Sutherland, who I believe is one of the principal developers of SearchFox, would be happy to see visual improvements to SearchFox. All right. So somehow we've got this background parent and background child. Let's maybe go one step back and take a look at the things that define background parent, background child, because these implement an IPDL interface. So what they implement this protocol, P background. What does this protocol do? What is this protocol for? It looks like it manages a lot. Jeez. VSync, UDP, like it's all over the place. Idle scheduler, gamepad stuff, cache, local storage, index DB. I'm worried that I'm a little out of my depth here, a little, I might be, I'm not sure I completely trust myself to fully analyze this, but it might take the full time that we're streaming. We might not get to the other bugs. We shall see. So there is a protocol, P background. It has some synchronous methods. It manages all of these things. And you can construct all of these different protocol managers on it, like these actors, like P background test, P background IDB factory. Oh, so mainly what I think it does is it like acts as a place where you can like spawn other actors. And then there's like storage activity, like any of the methods that start with P followed by a capital letter are probably a constructor for another protocol, like P background local storage cache. That's another protocol. P service worker manager. So the parent needs to implement all of these things. The child needs to implement these, I guess. I have to remember the direction. Let's maybe look at one of the simple ones. So apparently there's a function here that's only called on testing. That's flush pending file deletions. Let's see just quickly it being used, just to further our familiarity with the code. This be it? Not quite. We've got the same name, but manager is an index database manager. Excuse me. Quota client is a quota client. You know what I actually will do? Oh, here, impl. If we receive flush pending file deletions. What I'm going to do is I'm going to take a look at the point at which this was added. From P content to P background, Jan Varga, 2016. It calls flush pending file deletions and gets some usage info, checks the value there has changed. The flush call ends up in index database manager flush pending file deletions, which sends an async message to the parent, which then dispatches a bunch of runnables onto a background thread, which I assume does the actual deletion. That all seems pretty prone to races. That's just a guess, though. Maybe there are strong ordering guarantees that preclude that. Yeah, I think one of the things that pbackground does, if I remember correctly, is it allows background threads to communicate with one another over IPC. Normally it's the main thread that communicates to something else in the main thread of a content process or a different kind of process. But sometimes you want background threads to be able to communicate. And I think that's what background is supposed to do. So it's like, it's possible that there are a bunch of things that, like, this is just foundational infrastructure that other things build on top of. I'd love to find like a really, really simple example. Maybe if we look at the log, we'll see when something new was added and see if we can find something appropriately small. Port file creator helper. Like, what was that? Peek inside this patch. Lots of files got changed. So this isn't exactly the small patch I was looking for, I don't think. So maybe let's look for something else. Already, though, I'm starting to think that since pbackground is used to, like, when you shut it down, we're observing the shutdown for whatever. There were two threads. What were they? It was like shutting down thread local and then thread local for socket process. Socket process. I guess like we can have a pbackground, like a background thread in the socket process communicating with a thread in a content process. Maybe that's what's going on. Create background between content process and socket process. That's interesting. The socket process is like if we split out HTTP, like all their networking into its own process. I think that project is currently underway. You can actually turn that on in Nightly right now, I think, if I can remember the pref. I don't actually remember the pref, but... Okay, so you can be running in the socket process or you can be running not in the socket process. Good to know. Web MIDI IPDL files. How does this work? So Web MIDI is a thing that only got halfway done, I think, before other things got in the way. But maybe we can use this as an inspiration. So Q Dot, aka Kyle McCulis, developed all these structures and then created this P-MIDI manager protocol, which is managed by P-background. And there's the MIDI port protocol, which is also managed by P-background. And that's it. These functions were stubbed out and don't do anything. Let's see if there are other bugs in this patch. Other patches in this patch. Parent P background implementation. That's what we want. MIDI is in the sound format. Yes, there is a web MIDI API that is in the W3C website here. Has been implemented by some browsers, but not by Firefox. I believe the Chromium-based browsers have it. I don't know if Safari has it. Firefox does not have it. But you could use can I use to determine whether or not you can use it. Anyways, I wanted to go to, where did I want to go to? The implementation. Yeah, background, P-background implementation. So he creates this class, MIDI manager parent. Doesn't do a whole lot. This is exactly what I want. I want a very, very simple example of something that runs on P-background or with P-background. And then MIDI manager parent, the header, is similarly small. We include MIDI manager parent. We say that we implement this interface. We ref count it. We might be told to shut down. The child might tell the parent to shut down. Okay. A MIDI message queue. I don't know what that's used for, but it seems like a utility. Not part of the protocol. And then MIDI platform runnables. So these are different things that can run as events on a thread. I guess on the background thread. And then the service, runs on the background thread. I don't really know how MIDI works, but I presume that there's information coming in from a port of some kind. There's an interface and you're just getting like a stream of information. And I would imagine one of the things that we do for web MIDI is that we stream the information from the parent process, which is the ability probably to talk to the MIDI driver registered with the operating system. We can talk to that interface and then stream data to the content process that's actually using the web MIDI API. So here in this case, the MIDI platform service I think is running off of the main thread in the parent process, and it's streaming data from the MIDI interface to the content process. Okay. Base class for platform-specific MIDI implementations handles aggregation of IPC service objects as well as sending and receiving updates about port connection events and messages. Okay, that makes sense. MIDI port parent. So this also runs in the parent process, presumably. I presume that this runs in the parent process. If we've been told to open, so we receive a message that's like, hey, open up. Then we ask the platform service to open it up, and we pass ourselves as, I guess, a port or a MIDI port. And if we've been told to close, then we tell the MIDI platform service to close. So there's the MIDI platform service, which is like this, as a service, it's like this one-time thing that exists on its own. There's a singleton. And then there are these MIDI port parents that will, like, they're ephemeral. They'll start up, one will get instantiated when a web page tries to use the web MIDI API, and then it goes away, I guess, if that window goes away. And this makes perfect sense as a structure. MIDI port parent receives this message. Now, how does this, I'm starting, now that I understand more or less what this is trying to do, how does this integrate with P background? Like, what's the actor implementation for the parent P background thread side of MIDI manager represented in DOM by MIDI access? And I think the thing is that anything that implements P background is going to run off of the main thread. These are off main thread actors. That's the difference. That's, I think, the special thing about P background is it gives us a way to do off main thread actors. Let me just double check P background, see if there's any documentation out there that I should be referring to. Ho, there is. Maybe I should have just read this the whole time. P background is a mechanism available since Gecko 30 that builds on top of IPDL to provide a solution to common problems that arise when handling multiple threads in the Chrome process. For example, communication between workers and multiple child processes and other parent process worker threads. This article outlines what P background is and how it works. With P background is, that's a typo. I could probably just fix that up right now. What P background is. Publish. Okay. IPDL recap. It's a language that defines protocols, formalized versions of how two things across processes can communicate. The build time, the IPDL compiler generates a bunch of C++ glue code, and they used to specify how the Chrome and Conda process talk to each other and verify that Conda process is following the rules. Right. When you use a runtime every I should have just read this the whole time instead of going down into the web MIDI stuff. I should have just looked for documentation. So pro tip, see if there's documentation first. I've been doing this. I've been working in software for like a significant chunk of my life, like over a third of my life, and you'd think I would have learned this lesson. See if the thing that you're looking for already exists. Every protocol has two actors, a parent and child. These actors can live in different processes due to IPDL, which automatically serializes calls on one side and transmits them to the other. This is how we talk to each other with E10S. E10S is the multi-process project. It was short for electrolysis. Smurf D says, this document is last edited by M. Connolly. He must know this by hand. Oh, I hope not. I am now probably on the edited list. Yep, I am now on the contributor list. Great. I'm so happy about that. Hooray. But if people look at the diff, they'll notice I just swapped a word. So they'll know I'm not an expert. So all actors live in a tree. The tree is known as the top-level actor, an instance of one of a small number of top-level protocols. All actors in a tree live on the same thread and can only be used safely from that thread. The top-level actor for most things is p-content. This is true. This is what I'm familiar with, is the p-content actor, where almost everything that I've ever done with IPDL occurs on top as a descendant of the p-content protocol. Because what I've usually been doing is communicating from the main thread in a content process to the main thread in the parent process and back, and vice versa. So that's why you have p-content be the top level. I get it. So p-background is the top level background thread actor. For most purposes, this is great because the DOM is already bound to the main thread, but in some cases, we don't necessarily want to talk to the main thread. What if we want to talk to a different thread? Not every communication between the Chrome and Conda processes necessarily wants to go through the main threads of both or even either processes. For example, when we are uploading textures from the content process that's using like the old layers mechanisms instead of WebRender, We don't need to go through the main thread of the parent process. Instead, we can go directly to the compositor thread in the parent process by creating a new top-level protocol that connects the compositor thread in the parent processes to the main. Oh, that's interesting. So the main thread of the child process can talk to a background thread in the parent process. Okay, so it's not necessarily background thread to background thread. It might be one of those threads as main thread. This protocol is called pcompositor and allows us to bypass the main thread of the parent process, which trims the latency of texture uploads since they will not get bogged down if that thread is busy. Well, that's great. That's kind of what you want, is the ability to have these things operate off of the, like, without bothering the main thread. Because that's how you avoid, responsiveness issues. So writing code that works in both Chrome and content processes. A lot of code just works in the content process, but some things, such as APIs that need to manipulate files or device settings like geolocation, cannot run in the content process because it's restricted privileges. Intentionally so. Instead, these APIs must ask the Chrome process to do something on their behalf via an IPDL protocol. This has led to a rather awkward pattern seen in some parts of the Gecko code base looking something like this. If we're in the parent process, do this. Otherwise, send a message to do this thing. This can get unwieldy pretty quickly, so a better solution was needed. So p-background exists to solve such problems. Am I slurring my words? I feel like I'm slurring. I think I'm just really tired. I'm tired, and I might be slurring my words. I swear I haven't been like chugging paint thinner or something. I'm just tired. That's why I'm trying to drink some Coke, yo. That might give me some pep. Didn't they used to call it pep? I don't know if that's true, but I think that was once at one time part of the like slogan for Coca-Cola. It's like, put some pep in your step. All right. P-background exists to solve such problems. It connects a designated background thread in the Chrome process to any other thread in any other process. Oh, so it's a background thread in the Chrome process and any thread in any other process. That's interesting. So p-background allows us to bypass the Chrome process's main thread if used from the content process main thread. It bypasses both main threads if used from a non-main thread in the content process, and we can write process agnostic code because it can be used even from another thread in the parent process. Oh, I see. So it means that the child might not even be in another process. It might just be in another thread in the parent process. And I think that's how we got off-main thread compositing working at one point, was to have the compositor, or like the compositor, I think this is how we were able to do like the compositor process so easily, is for the longest time we had the compositor thread exist as a p-background thread in the parent process. And so we had these background threads in the parent process communicating with the compositor thread, which was also in the parent process. And then we spun out the compositor thread into its own process. On Windows at least, we have what's called the compositor process, or the GPU process, and that has a background thread. And we were able to use p-background still. We didn't have to like change anything except how we launched that thread, and that saved us a bunch of headache. Actually, I don't mean to make the work seem like crazy simple, but it was a lot simpler than what it could have been. Because once we had the off-main thread compositing working, having it be off-main process was a much simpler a much simpler proposition. Okay. Sorry, I'm receiving some messages, and I just need to check these real quick. Make sure that there are no fires for me to put out. 1 second. Oh, yeah, I want to point out, if you're looking to help, if you want to help boost the news about like multitasking and picture-in-picture, check out this blog post, check out this tweet, retweet it if you have Twitter, because that will help get it some traction. If you want to like blog post or help spread out the news about the blog post that I wrote about picture-in-picture, then you can retweet this tweet from the Moz Hacks blog post. Yeah, okay. So let us continue. So P background, now that we're talking about P background, there's all sorts of things that it might be doing. All sorts of things. It's everything that runs on the background in P background. And if any of them are writing to disk, we might have a problem. Like, for example, well, let's go back down to the shutdown, xbcom thread shutdown line, which was line 1735. What? Oh, sorry, I'm in the wrong file. Let me go back here. Oh, there's two thread observers. There's one in the parent and there's one in the child. It looks like, yeah. So Heist looks like it's taking care of the, he's taking care of the parent process one. And now, but he says it's just for the IndexedDB actors. Child impl, shut down. Where is this register? Child impl. What's the constructor? Constructor. We construct a child impl in parent impl. So you can construct it in the same process. So it might be running in the same process, and it might not be. Right. Like what we were describing with the compositor, because it used to be running in the same process and sometimes it wasn't. So the child may have seemed like it was a different process, but it wasn't. It was another thread. Okay, so we can create the actor for the same process, and then we can, what is this? Create, get or create for current thread. Call from here, background child. So lots of these things. So like lots of background childs get created. Broadcast, cache storage. P background. So here's what I'm gonna write. P background is very is complex. It seems it's used so that background threads in the parent process can communicate with other threads in what did the documentation say? Right. It can be used even from another thread in the parent process. Right. It's used. Parent process can communicate with other threads, so that a non-main thread in the parent process can communicate with other threads in content processes, or even within the parent process, using an IPC, using our IPC infrastructure. Lots and lots of things seem to rely on it, including IndexedDB. What else? P background, cache, some cache things, cache storage. What kind of cache is this? Yeah, I should look this up. Pcache storage. Service worker cache. Service worker caches. Service workers in their caches. Gamepad. And soon the socket. I think right now it's like the socket stuff. Use it. UDP sockets. Socket. UDP sockets. There's more. But the indexed DB one caught my eye first. The indexed DB one and indexed DB and service workers caught my eye because they definitely attempt to persist things to disk. So I think this needs discussion. So this line that I'm looking at is the child shutdown observer, which may or may not actually be running in the parent process. Presumably, though, it's possible that it's running. We might need to do a deeper dive here to determine which protocols managed by pbackground actually use a separate process, actually have their children running in a separate process. And then from there, we can probably determine which ones are which protocols are safe to skip when shutting down the main thread, skip when running xpcom shutdown threads. Wow, that was a big one. That was like a lot, but I feel like I learned something there. pbackground is like really, really big. It's not just one thread. It could be a whole host of threads. So we can't really say whether or not, without like a deeper dive, and I don't think I'm prepared to do that on my own. Because for each thing that pbackground manages, each of these needs to be examined. Or rather, the things that it manages right here. Each of these needs to be examined to determine whether or not they run out of the parent process, and if the child side of that protocol, if it were just suddenly interrupted, whether or not that would be okay. I don't think. So I'm gonna say like. So I think this is a bit big for me to chew on my own. It might be better to split out each protocol that pbackground manages and examine them one by one. Okay. Watcha! I'm not going to do these other two. I think I'm going to skip forward. Let's do something else. You know, I've done this one thing. Let's work on the pop-up blocking fission port. Let's work on that for now. See if we can write some code today. Just as a change of pace. Let me pump up the font a little and resize the window. So the pop-up blocker is something that we want to work with fission enabled. And right now, I think it kind of does. But let me show you where we're currently at. There's this site that I've been using for pop-up blocking testing. It's great. It's popuptest.com. Put your pop-up killer to the test. This site looks like it was built. It kind of looks like a fake site. Like something you'd see if you went to, like, if you typed in Google with one O instead of google.com, or Facebook with, like, but FACEBOOQ accidentally or something. You go here. But this is actually like a legitimate pop-up testing site. So I click on this one, and like this is the Firefox pop-up bar, and it's telling me that, like, yeah, I blocked some pop-ups here, and that's great. So this is working. This is using the new sort of fission compatible pop-up blocking code. Now the one thing I want to do is see if I can force that page to run in an iframe to see if it works in an iframe. Because I'm very curious whether or not this will work. So what I'm going to do is I'm going to go to jsbin.com, create an iframe, and say that the source is that. And I'm going to make the width 500 and the height 500. Cool. So here we've got, this should be, oh, I need to have fission enabled. My bad. Let me enable fission. Fission, auto start, true. So let's copy that. Or actually, what I'm going to do is I'm going to publish it. All right, I don't want to add a library. Save snapshot. I don't know if that worked. File, publish. Oh, can't. Let me just JS Fiddle, I think, will let me do this. .NET. Here, I don't even need the preamble. Just need this. And I got a feeling because I enabled fission, I definitely need to restart. But let me save this. Save. So we're going to go to this page again. I'm going to bookmark this page. And now let's restart the browser. So, JS Fiddle. Oh man, where'd my page go? Oh, it's here. Now why isn't this showing up? Can I not load an iframe here? Invalid X-frame options. Oh, come on. I need to frame this thing. Go to popuptest.com. All right, fine. JSBin it is. We had this working in JSBin. Ah. Popuptest.com. Now it's not working. Why isn't it working? Block loading mixed active content. Oh, come on. All these protections. I'm actually trying to do something kind of... Well, all right. What if I host just an test page, test. It's like subframe test, subframe pop-up test. All right. So I need let's get the classic starter there for website. I'm gonna change this to out of process iframe pop-up test, and in the body we're gonna put an iframe, and we're gonna say that the source is popuptest.com with equals. I'm just gonna do it. I'm gonna put it in attributes because I'm evil and because I don't care. All right, so let's open this up. I'm gonna start up a web server, Python, simple HTTP server. Start that up. I'm gonna allow that, and we're gonna browse to localhost 8000. Okay, so now we should have an out of process iframe. Now I'm actually running this not in the right build. I wanted to run this on my test build. So let me my test build's over here. So we're gonna run this. So we're gonna serve it up again. Yay! Okay, so let's see if we can block some pop-ups. Click. Hey, we blocked some pop-ups. Great news. So the new the out of process iframe pop-up blocker works correctly. Yeah, because this frame's PID is 79497, and this tab's process is 79496. Okay, so we have out of process pop-up blocking working, which is great. However, I want to try and clean up the code a little bit. I want to try and improve the code a little bit. There's some complexity here that I think we can do away with. And while I'm here, I figured I'd try that out. Hang on, I'm just answering a question from someone. All right. Also reach out to... Just answering a question from someone. Okay, so what are the things that I wanted to do today? I wanted to work on the pop-up blocking thing, and I wanted to change the infrastructure. So the way it currently works is each frame gets a pop-up blocking child that collects an array, that holds an array of pop-up data, some of which is internal, not to be sent to the parent, and some of which is sent to the parent for displaying in the menu pop-up. The menu pop-up for allowing you to select which pop-up you want to actually open. So, yeah, each child has a collection of pop-ups that it stores. And when when does it clear that list out? Pop-up blocking child. When does it clear that list out? Remove irrelevant pop-up data. We go through the pop-ups, we get the internals. When we do a page, I think page hide? When we do a page show, we check to see if any of the stored collected pop-ups no longer match the document that is showing, and if so, evict them. And then we update the blocked pop-up data, which I think was this message. I think I just renamed it to send. Let me just put this back. Update blocked pop-ups. And that sends a message to the parent saying, like, these are the current pop-ups that we have. So the parent receives, if so, evict them, and then we send up a new list of pop-ups to the parent. So one of the things I was thinking was, why is it that we only send these well, notice that there's like an API where like the child process can be asked for information on the blocked pop-ups, like get the blocked pop-up list. I think that's actually used for displaying in the drop-down. What did I want to refactor here? I'm trying to remember what it was that I wanted to do. Maybe it's, what is pop-up blocking update blocked pop-ups for? What's still missing? Update blocked pop-ups. Yeah, what was this put here for? So the reason I have the WTF there is because I'm taking this patch over from someone else. And I have a feeling this was never meant to be here. Receive message. Get blocked pop-up list. And where is this sent from? Parent process queries retrieve list of blocked pop-ups. You know what I'm gonna do? You know what I'm gonna do actually is I'm gonna avoid trying to like save the world and make this better. I'm just gonna get the feature ported and then put together a list of ideas for things to improve in the future. I'm just gonna get the feature ported though as is. I think that's my plan. Okay, so here's what I'm going to do. Retrieve list of blocked pop-ups. That's going to return Oh, that's why. So one of the reasons why we're not just sending the one message is because we need to like send a message to all the content processes and query them for the list of blocked processes or blocked pop-ups. That's why this is like that. Is that the original implementer was trying to avoid having to like send a broadcast a message and then sew up the list. So maybe I can't do it this way anymore. Hang on, I'm just trying to think my way out of a paper bag here. All right, so we could have a component in the parent process whose job it is to manage, like, so each frame will get these DOM pop-up blocked events with information about the blocked pop-up, which we can then feed into the parent. The parent can like cobble these all together and cache them instead of having to query for it every time. Could do that. Or you could just ask, like, how often do you open up the allow pop-up list? You send a message. I've got all these pop-ups. Message goes up to the parent. Parent gets updates about it. I think my main complaint with the way that the current implementation works is that it does all this bookkeeping in the child process to determine, and bookkeeping elsewhere in the parent process to determine which pop-ups have been notified about. And I feel like that can be simplified by having the content process just send a feed of like pop-up events to the parent. And when the parent receives one, it goes, oh, this is a new pop-up. Rather than like adding it to a list and then like having to determine, okay, which one of these is new. We know which one's new because we added it to the list. We lose that information whenever we send an updated list from the content process to the parent. We just get a new list and we swap it out, and then if like we could do a diff or something, but like what we really want is like to flush the list anytime. When do you clear the list? You clear the list on page show. What we do is we get at the internal window and requesting window and requesting document of each pop-up. And if we are showing a window or currently showing a document that does not map to any of the ones that are currently in our pop-up data, then we remove that entry. Remove relevant pop-up data. Now, why was this done this way? I think I'm going to try and go back in time a little bit to determine whether or not there's like a bug here that's trying to be like captured. So we're going to see the full diff. What was this based off of? Pop-up blocking was originally from browser content. So diff. There you go, parent. Then we're going to review the file. We're going to annotate the file. This might take us deep into the past here. This stuff. Here, page hide shouldn't junk all pop-up data indiscriminately. This wasn't that long ago. This is 2 years ago. If the pop-up blocker notification icon on the location bar disappears quickly and the user is not able to click on the button to open the pop-up blocker options, fix hiding the pop-up icon when navigating the browser. It's clearly an attempt at a minimal test case of some sort given something that happens on some other site. I'm a bit confused because I'm only opening with self-frame. Pop-up blocker doesn't cope well with multi-frame documents right now. It looks like if you create a pop-up and then page hide fires for a frame, remove the pop-ups for the entire top-level browser. Oh, we should only care about pop hide events for the top-level document. I think that makes sense. If it's just a problem that the subframe page hide makes the icon go away, then it looks right to me. I wonder if there's something worse broken here. So really, we just want to make sure that like we don't clear out the list of pop-ups if only one frame unloads. Okay. But because we're going to be managing the page data with per frame with page pop-up blocking child, what we can do is if we page hide, we send a message to the parent saying we page hide, and that clears the list. So have the parent manage the list. Have the parent manage the list. Yeah, have the parent. So here's what happens. The pop-up fires, let's say 1,000 pop-ups fire, all in different frames. And each frame is in a different process. All those send messages to the pop-up blocking parent with the information about the pop-ups, information that we can like use to recreate the pop-up if needs be. And then inside the parent process, upon receiving those messages, for a particular frame, like a particular browser tab, we sum the lengths of each of those arrays to determine how many pop-ups there are in total. We create some kind of order. Maybe we just walk the browsing context tree to create the order of pop-ups to list in the drop-down. Which menu item? I kind of like that. So I'm going to back. Originally, I said that we could just like do a straight port and not like recreate, redo a bunch of this stuff. But I think we have to. We have to because we're changing some of the fundamental principles of how the pop-up blocker works. So I'm just going to write down my thoughts and then I'm going to end the stream because it is 2:30 and it's time to end the stream. But here we go. My thoughts are, I think we should have a per browser object called pop-up blocking browser. Pop-up blocking browser, which can have one or more pop-up blocking parents. When a pop-up is blocked, the pop-up blocking child adds it to a list on idle, on sufficient idle callback. We send that list to the parent. Parent receives, pop-up blocking parent receives the list and gets at the associated browser's pop-up blocking browser and registers with it if not already registered, and then informs it of new pop-ups, including how many. When the notification displays and can be updated dynamically. When the user clicks on the button to list pop-ups, construct the list using the information from the pop-up blocking parents. So the pop-up blocking browser can construct the list using the information from the pop-up blocking parents that are registered with it. Can construct the list using the information from the pop-up blocking parents that are registered with it, walking the browsing context tree in order, or we don't even need to walk the browsing context tree, just iterate the list of pop-up blocking browsers that registered in order and construct the menu list that way. Each menu list object will have a pointer, a reference, expando reference to the pop-up blocking, or we'll have an attribute. We'll just do an attribute browsing context ID and then index, where which allows us to refer to a particular pop-up. When the user selects that menu item, we look up the pop-up data in the parent process and send it back down to the child, which then reconstructs the pop-up. I think that's what I'm going to do. All right, folks. Wow, it was not a whole lot of writing code today. It was quite a bit of reading code and understanding code and just kind of mulling things over. I hope it was okay. We spent a lot of time just kind of watching me think. I'm also a little tired. I apologize if I was a little slower today, but that's how it goes. Thank you so much for watching episode 203 of The Joy of Coding. I hope that was interesting, and I'll see you next week. A reminder that there's an episode next week, but no episode the week after or the week after that. So there we go. Thank you so much. Let me transition the screen. Take care. Oh, now my tablet fell asleep. Hold on. Take care. Bye-bye. The Joy of Coding. See ya.